Hi everybody, I will start my today another coding practice. So this video is a follow-up of the previous video, which was, in which I solved meeting rooms number 2. So in my previous video, I used the line sweep to solve this question. I mean, voting plus line sweep. Yeah. But in this video, I will solve this question in another approach, which is heap. I will use a heap. Okay. So let me get started. So the question itself is something like this. So I'm giving an hour of meeting time intervals and return the minimum number of conference rooms required. So basically, the minimum number of conference room required is equal to, this means the um, max concurrency of multiple rooms. So say if there is a meeting 1 to 3 and 2 to 4, then in the time from 2 to 3, there are two meetings concurrently, held. So in that case, we need two rooms. So in that way, I will find the maximum concurrency and then that's the answer. And in my previous video, I used the sorting and line sweep with the events, list. So in this question, I will use another approach, which is using the heap. So firstly, I will use an example to demonstrate my idea. So let's say the meetings are like this. So in this way, okay, let me see. Okay, let me do it in this way. So in this case, and maybe this is good. Yep. In this case, the meeting rooms number of, max concurrency is 3 here. And to find it out, minimum number. I will think firstly there is a meeting here, it starts here, and then the next meeting starts here, and the third meeting starts here. Now the concurrency is 3. And after that, there is a meeting which ends at here. So here, this one is popped out, and now the minimum is, concurrency is 2. Then I find this, and this meeting is popped out, and we have only one meeting concurrency. Then I find this. Okay, let me change it a little bit. Then I find this. This is a new meeting, so now concurrency is 2. Then here concurrency becomes 1, and then concurrency becomes 0. So in this way, so far this is quite similar to my previous approach, which is building the event array and updates the concurrency one by one. But in this case, I will use the heap. So firstly, I will sort the event with the start time. So now all the events are sorted by the start time. And I will basically iterate these events. Intervals. And then, in this case, let me change that a little bit. So let me do it in this way. Oh, sorry, it's okay. Yeah. So in this case, I get this one, get this one, get this one. But before this one start, this one and this one is popped out. So I pop them out. Then I take a look at this one and plus 1. And then I find the remaining two ones. So it should be, um, yeah, decremented by twice. And in the end, the concurrency becomes 0. Yeah. So that being said, I think I can use yeah, heap for that. So basically, the meeting end, which should be popped out, removed from the concurrency is this, which, so I'd try to take a look at the smallest one first. Sorry, the meet interval end, which is the smallest. So I will always take a look at the smallest end, earliest end. Then, if it before the current interval, I will remove them. So basically, I add element to the kind of correction or pool. Then I pop out the item for the smallest, I mean, the item with the smallest end. So that kind of operation is quite, suitable to be handled by the heap, mini heap. I will use. Okay, so basically, I will, I'll try my ideas. So firstly, I will do sort intervals, then traverse intervals, and firstly pop out and did intervals. Then increment concurrency by 1. Yep. Then finally, I will return the max concurrency. Yep. Okay, so that being said, let me, that's the implementation. Yeah. But I think I can do the time complexity analysis first. So assuming that there are n intervals, firstly I sort the intervals, which will take n log n. And after that, I will traverse the interval. So it will take O of n. And inside of that, I do the pop operation of intervals. And yeah. And also, obviously, oh. Then, yeah. So I need, heap pop out operation and heap push element. Each of them takes over log n time. So I don't know how many intervals are popped out in each interval traversal, but I can say in total, this push operation occurs exactly n times, and pop out operation also occurs exactly n times because is a number with intervals. So I can say this part, pop out and push operation total time complexity should be n log n. So in total, it should be n log n time complexity. For space complexity, I need the firstly I need the space for temp sort. Temp sort, which is a Python standard sorting algorithm, uses the O and extra space, so that's what I need. And also we need the heap whose size is up to O of n. Exactly n. So these are the required space, so it should be O of n. Okay, so that being said, let me start let me get started. So Okay, I will keep track of them. And here, first thing I will do is I will pop up from the heap. So yep, I will do this. Then now the ends intervals which ends before current interval is popped out. So now I append current end to the ends heap. Yep. Then the current interval should be, oh, I don't have to keep this current concurrency because current concurrency is exactly the number of element in the heap because it's the pending, inter I mean meeting, Okay. Yep. So with this, I will update max concurrency. Then I will return max concurrency in the end. Okay. So one thing I'd like to take care is all about the end. What does this end mean? So say the meeting is 1 to 2, or maybe 1 to 3 and 3 to 5. Let me think if how many meetings I need for this. So probably I can think one is a timestamp, 5 is also the timestamp, and meeting is in this period. Yep. So that being said, I need only one meeting room because the max concurrency is 1. So let me quickly check this. Check line 37 with this. So if I mean if the start is 3 and end is also 3. Okay, so when I say I'm looking at the time 3, I'm actually seeing this range. So immediate, I can say 3.00001 to 3.99999. So I will call this, I mean, I'd like to get the concurrence of here after timestamp 3 is treated. So let me say, if the start is 3, I'd like to pop out all the intervals which ends 3 or before. So this is good. And I should pop this, I mean, interval to the, this. Okay, that's good. So I'm pretty sure this is good. So let me walk through with some examples. So let me do with a very, I mean, easy example like this and this. Okay, so in this way, let me do it in this way. And the expected value is 2. Yep. In this case, actually, in the end, here, ends may have some element, but it doesn't matter. Because, if the mating ends, I mean, the number of concurrency is reduced. But what I'm interested in currently is only the max concurrency. So I don't have to take care of it. So that being said, when I get these intervals, firstly I sort it and I get 1, 4, 2, 5. Then I will start max concurrency 0. Then in line 40, I will get start 1 and end 4. Then because length of the ends is now 0, so I don't have anything to be popped. I go to line 43, and now I append 4 to the heap. Yep. Then here in line 47, current concurrency is 1. The max concurrency is now 1. Yep. Then I come back to line 43 and I will take a look at 2, 5. And I can see that how this, no, yeah. So currently length of ends is more than 0. I have one element, so I will take a look at this. And n0, which is 4, is bigger than the, wait, 1, 4, 2, 5. Yeah. So let me change this to say 5, 10. So in this case, max concurrency is 1. I'd like to cover all of the lines, so I decided to use this one. So in this case, n0 is 1, no, 4, and start is 5. So this is true. So element is popped from the heap. So now heap is empty. Then in line 46, I push current and 10 to the heap. It's now like this. And then in line 48, current concurrency is 1. The max concurrency is still 1. So I will return 1. Okay. Sounds good. Yep. So I've covered all the lines. So let me execute my code. Good, accepted. Okay, now it's accepted. Great. So let me quickly wrap up today's practice and finish this video. So this is the second video about meeting rooms number 2. So in this question, I'm given the list of intervals. Then my task is to find the maximum concurrency of those intervals actually. And in my previous video, approach 1, I use line sweep. And in this video, I use as a solution 2, I use sorting plus heap. Yeah, mini heap. So the main idea is that I sorted the intervals in ascending order. Then I traverse the intervals and I will keep track of the each end of the intervals and put it into the heap, mini heap. So while I traversing the intervals, if I find some end, timestamps which are outdated, I pop out from the heap. And the good thing is that the size of the heap is exactly the current concurrency. So I keep track of it. I take a look at it every time. And finally, I return the max concurrency. Yep. Which is, exactly the max size of the heap. Okay, so let me finish my today's practice with this. Thank you so much. Bye.